Write an equation that represents the relationship shown in the tables. We're going to look at how there's a pattern between the x values and the y values. How can we get from one to the other? Well, in here, if I look at this x value, how could I get to the y value? You might notice that you could subtract 1, but if we tried that over here, 4 minus 1 doesn't give us 2. So subtraction is not the pattern that is used here. What's another way I can get from 2 to 1? I can split it in half, or I could divide by 2. If I use that same strategy, does it work here? 4 split in half is 2, or 4 divided by 2 is 2. So we're going to write our equation. The y values are found by taking half of the x values. The y values are equal to half of the x amount. Try and write an equation for 1, 2, and 4. This says, consider the table shown. Write a situation that shows the relationship. Well, 1 plus 2.5 would make 3.5, but 2 plus 2.5 is not 7. What about a multiplication relationship? 1 times 3.5 is 3.5. 2 sets of 3.5 is 7. A situation that might be related to this, you could be selling things for pounds, and then this is the cost of all the pounds that you purchased. It could be hours and pieces built by a machine. We're going to use cost for pounds. With money, we use 2 decimal spots, so 3.5 can be rewritten as 3.5 with a 0, and that doesn't change the value of that decimal. B, what is the constant of proportionality? Well, that constant, each pound, is 350, so the constant of proportionality is 3.5. Remember, we use K for representing the constant of proportionality. And then it says, what does it mean in the situation described in part A? Every pound of apples costs the same amount of $3.50. Write an equation that represents the situation in part A. We use constants of proportionality to write equations in this format. Y equals kx. We said that our constant of proportionality was 3.5, so we can replace k, the constant of proportionality, with the number that it represents. And it also says to define our variables. X is the pounds of apples. And Y is cost in dollars. Then it says graph this relationship and label the axes. This is the x-axis and this is the y-axis. So this one is going to be labeled with pounds. And this one is going to be labeled with cost. So we know that 0 pounds is going to cost $0. 1 pound is $3.50. That's almost to 4. 2 pounds costs $7, which is in between 6 and 8. 3 pounds cost $10.50. 4 pounds was $14. And then we're going to draw a line through those. Well, we'll just sketch it since my line tool isn't working. This arrow indicates that the more pounds we spend, the more it's going to cost, and that it continues on. We can buy more than 4 pounds. We can buy more than what shows up on this grid. 2. Look back at the work from problem 1. In part B, you calculated the constant of proportionality. Highlight the constant of proportionality in the table, in the situation, in the equation, and in the graph. Here it is in the table. Whoops. In the situation, here's our constant of proportionality in part B. And then in the graph, that constant of proportionality is this first point here, where our x value is at 1, and our y value is between 2 and 4, right there at 350. For this next activity, we're going to draw 2 cards, one from the first box and one from the second box. We're going to represent the proportional relationship from the first card in the format that it asks us to on the second card. If you aren't in person and you're just online, you can use the example that I'm going to do here. Here you can see the 2 cards I drew. The first one has a graph, and then we're going to rewrite the relationship that we find in the graph as an equation, because that's what my second card asked us to do. So to find the constant of proportionality from a graph, we're looking for points in the graph. I see this point 0, 0. I see the point 2, 3. And I see the point 4, 6. To find that constant of proportionality, we can use y values divided by x values. So here, 0 divided by 0 isn't going to work, so we're going to use different points. We can use 3 divided by 2, and then the y value divided by the x value in the second point is 6 divided by 4. If we evaluate those, 3 divided by 2 is 1.5. 6 divided by 4 is also 1.5. So k, our constant of proportionality, is equal to 1.5. To write it as an equation, we use the template y equals kx. The y is still there, because that's the variable they used. The equal sign is still there, and the x is still there. The only thing that we're going to swap out is the k value. We found that k was equal to 1.5, so our equation should say y equals 1.5x. Problem 3. Henry purchases 0.6 pounds of almonds for $5.25. The cost of almonds is proportional to the weight of the almonds. Complete the table for this relationship. Enter values for the pounds of almonds, P, and then determine the corresponding value for the total cost, C, in dollars. Calculate and highlight the constant of proportionality. So to start, we need to divide 5.25 by 0.6. And that's going to tell us the constant of proportionality, which is 8.75. Now that we know the constant of proportionality is 8.75. That means that 1 pound should be $8.75. Then we can check. If I do 8.75 divided by 1, does it keep the same constant? Yes. Anything divided by 1 remains the same. Now let's look at how much 2 pounds would cost. If 1 pound is $8.75, 2 pounds should be twice as much. So we can multiply by 2 for $17.50. Then when we check, is $17.50 divided by 2 the same constant? Yes. It also comes out to $8.75. What is the constant of proportionality in this relationship? It is 8.75. Remember, we use K to represent the constant of proportionality. What does it mean in this situation? It means that each pound of almonds costs $8.75. Now write an equation for this relationship. Highlight the constant of proportionality. You can see here that they use P and then C instead of X and Y. So C is like our Y value, and P is like our X value, pounds and cost. So we're going to write C equals, and we're replacing K with our constant of proportionality, and then P for pounds. And it asks us to highlight the constant of proportionality in the equation. D, graph this relationship and label the axes. Highlight the constant of proportionality. This is pounds and cost. So 1 pound was $8.75. 2 pounds was $17.50. 0.6 pounds was $5.25. Oops. So highlighting that constant of proportionality, we're looking at 1 pound costs $8.75. There are several different ways that we can represent constants of proportionality or proportional relationships. Those include tables, graphs, and equations. Think about which one is the least challenging to determine the constant of proportionality. And then also think about why it's beneficial to be able to identify the constant of proportionality. Why is that number helpful? When you're ready, feel free to check back in for lesson 9.